Module 1, Lesson 3, Copy and Bisect an Angle. So let's start off with some vocabulary here. An angle is formed by two rays with the same endpoint. The rays make up the sides of the angle, and the endpoint makes up the vertex of the angle. So let's take a look at our diagram here. We have a point A and two rays that come off of that point. A is the vertex of the angle, and ray AB and ray AC make the sides of the angle. We name an angle in three different possible ways. The first way is by its vertex. So the vertex here is point A. We would call this angle A. This is only possible when there is one and only one angle that has point A as its vertex. So if we have multiple angles that use point A, no, not going to happen. The most appropriate way to name an angle is by a point on each ray and the vertex. So we have 2 points here, one on each ray, and we would name this angle BAC or angle CAB, another case where order does not matter. But do notice that when you are using 3 points, the vertex must go in the middle. This is not an option. So you always know which point is the vertex because it's the one in the middle. Again, this is the most appropriate way and the longest way to name an angle. And last here, you can sometimes use a number. This angle is labeled with a number 1. We could call it angle 1. The interior of an angle is the region containing all of the points between the two sides. So this is pretty straightforward idea here. Here's the inside of our angle. All of these points are inside the angle. They would be on the interior. The exterior of an angle is the region containing all of the points outside of your angle. So all of this stuff out here. Again, very straightforward, but these terms are going to be useful to us when we are describing what we're going to be doing in the lesson. We classify angles according to their measures. Angles are labeled in degrees. We use our degree symbol. And we have discussed before that to indicate the measure of an angle, we use the italics lowercase m. So this says the measure of angle A is 62 degrees. So this, you will read this, the measure of angle A, which turns out to be a number. This should be review. Acute angles are between 0 and 90 degrees, 0.0001 degree to 89.99999. A right angle measures exactly 90 degrees and can be marked with the right angle symbol. An obtuse angle is between 90 and 180 degrees, and the one that is going to be extremely useful to us is called a straight angle. Now, a straight angle measures exactly 180 degrees. And what is a straight angle? Yep, it's a line. Those are going to be extremely useful to us. Our last angle type here is a zero angle. And a zero angle measures 0 degrees. And you say, well, how can that possibly be? Let's take a look. We have a point that is our vertex. And we need two rays, right? We have two rays that share that vertex. Let's draw our first ray. There's one side of our angle. Now let's draw the other side of our angle. Where would we draw it if it were only opening 0 degrees? We would draw it directly on top of the other ray. This is a 0 angle. They are collinear rays, form a 0 angle. Another important idea for us is adjacent angles. What does adjacent mean? It means next to. So angles that are next to each other. Adjacent angles are coplanar, two coplanar angles with a common side, a common vertex, and very important here, no common interior points. So let's take a look at our diagram. Angle 1 and angle 2 are adjacent angles. They have a common vertex, a common side, and no common interior points. They do not overlap. Angle 3 and 4 are the same way. They have a common vertex, a common side, and we have angle 3 and angle 4, and they are separate angles. They share a vertex and a side, but no other points. Some major ideas in this lesson are going to be, if you are given a line, so take a look at our line here, you can imagine that it splits this plane into two sets. And if we take a point in the top set, P, and we take a point in the bottom set, Q, we can say that the segment formed between P and Q will always intersect the line. So when you look at it, it makes a lot of sense once you go through it. We also have a segment that intersects the sides of an angle. So we've got A and B are where this segment intersects the sides of an angle. If we are given any point C that is in the interior of this angle, so we're going to choose a point C, anywhere on the interior of the angle, we can say that ray OC, so starting here at O, which is the vertex, passing through C, always intersects that segment. And that is going to be a useful idea for us in this lesson as well. Our definitions, postulates, and theorems. A lot of really good, really important definitions and postulates in this section. So let's start off with the definition of supplementary. Supplementary just says two angles whose measures have a sum of 180 degrees. These angles are called supplements of each other. So now when we look at our first diagram here, angle 3 and angle 4, they're a line. They are obviously supplementary, right? That line makes a straight angle, so those two angles have to add up to 180 degrees. Angle 3 and angle 4 are supplements. Their measures add to 180. Now, our next angles over here, angle B and angle C, they aren't adjacent, they aren't touching, but they are still supplements. How come? because the measure of angle B plus the measure of angle C equals 180 degrees. That means they are supplementary. It's the definition of supplementary. Their measures add up to 180. So they are still supplementary angles. They are supplements of each other. Our next definition is a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. What's an opposite ray? It's our two rays that share an endpoint and form a straight angle, form a line, right? The angles of a linear pair form a straight angle. So they are next to each other and they form a line. Definition of midpoint. A midpoint tells you exactly what it is. It is the point in the middle. It's a point that divides a segment into two congruent segments. So if we look here, B is the midpoint of segment AC, which means we know that segment AB and segment BC are congruent, which means they have equal length. The definition of bisect means to divide into two congruent parts. So anytime you see bisect, you're thinking two congruent parts. If it's a segment bisector, you can have a line, segment, ray, or plane that intersects a segment at the midpoint. It will divide the segment into two congruent segments. If you have an angle bisector, you have a ray that divides your angle into two congruent angles. And your angles will have equal measure. So we can say that ray AY is the angle bisector of angle XAZ. And notice here our angles are marked congruent because that's definition of angle bisector. And I like to offset my congruent markings so they're easier to see. The last two here we use a lot. The linear pair postulate, remember postulates are accepted as fact, says if two angles form a linear pair. So if we have a linear pair, what does that mean? If they are adjacent and make a line. Then, so if we have a linear pair, then those angles are supplementary. And what does that mean? It means they add to equal 180 degrees. So if we look here, we have a linear pair. They are adjacent. They form a line. We can mark that and say 180 degrees. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. And last but certainly not least is our angle addition postulate. This is one of a family of addition postulates. And all of them simply say, oops, P-I-E-C-E, piece 1 plus piece 2 plus piece 3 plus piece 4, you can have as many pieces as you want, equals the whole thing. It says if point B is in the interior of angle AOC, so we have a point B here, an angle AOC, okay, then the measure of angle AOB, that's this guy right here, plus the measure of angle BOC, that's this guy right here, is equal to the measure of angle AOC. So basically, blue plus green equals purple. And remember in a couple lessons ago, I told you these are numbers. So guess what we can do with these? Anything we can do with a number. I can subtract the measure of green angle from both sides and end up with the measure of blue angle, because these cancel. I did opposite operations. So that will equal the measure of the purple angle minus the measure of the green angle, because purple and green are not like terms. So isn't that fun? We are going to construct the angle bisector, so using our compass and straight edge. And what I want you to do first is think back to Euclid and the circles and triangles that we drew in Euclid's proposition. So we had these two circles and they had the same radius. And what happened when we drew these two circles with the same radius? We ended up with intersection points. Now, we used them to draw equilateral triangles. But let's think about this from another perspective. What happens if we connect those intersection points? What are we going to get? We are going to bisect that segment. We're going to cut that segment in half. And we can use that idea and the interior of an angle idea, that we can draw a point on the inside of an angle that will always intersect the segment, to bisect our angle. So the first thing we want to do is to set up the radius of these circles that we want to draw. So it doesn't matter what radius you choose here. The larger your compass, the easier it's going to be to use. But it doesn't matter. We just draw the circle, and we can draw the whole thing or not. It doesn't matter. And all we really want out of this are these two intersection points, because those are going to determine the radius of our circle. We have a radius right here for a circle. So now I'm going to take my compass and I'm going to set it to this length, and then I'm going to put it on the intersection point and draw that circle. And look, it goes through the vertex. Now I'm going to keep that same length because this is my other radius. I want my radii to be congruent. And I'm going to put it on the other intersection point and draw my other circle. Do you see Euclid circles coming up there? So we now have an intersection point here and an intersection point here. One is on the vertex of the angle, one is on the interior of the angle. And now I can take my straight edge and connect those 2 points, and we have an angle bisector, and we can mark our 2 angles congruent. So that first yellow circle, all it did was determine the radius of the 2 circles that we were going to draw to get our intersection points. We are going to copy an angle using constructions, and we know that angles are made up of 2 rays that intersect at the vertex, that share a vertex. So the first thing I'm going to do is simply draw a ray. And here's my vertex. Now we are going to use our compass to measure a distance. We are going to put our compass on our vertex and simply draw a circle. Now, why do we want this circle? Because we are looking for the intersection points. We'll call this intersection point 1 and intersection point 2. Doesn't really matter. So we have these intersection points. So if we take our compass and we use this same measurement to draw a congruent circle, so I'm going to move down here to my other ray, put it on the vertex, and simply draw another circle that's exactly like the circle that we just drew, we have one of our intersection points. That's intersection point 2. And we know that these are radii of our circle and they're all congruent. So we need to find the other radius in this other circle that's going to make our angle, to make our congruent angle. Now, the cool thing about this is check this out. From there to there is a length. And what did we learn at the very beginning? Our compass is very useful for measuring lengths. Notice here, I can draw a circle with that radius. I can draw the whole thing if I want to, don't have to. I can draw another circle that intersects at that other point. So I'm simply going to use this same length, move my compass down here to point 2, and repeat what I just did. And look at that. There's the intersection point. There's the intersection point that matches up with point 1. And I can just take my straight edge and draw a ray. And now I can say my two angles are congruent because all of these pieces are congruent as well. We just measured that length with our compass. I hope you enjoy the constructions.